Okay, I'm going to do one D and E. They're related, just like you and your sister, if you have one. Hopefully she doesn't boss you around like mine did, but it's okay. Made it stronger. That's what she'd probably say. All right, gotta love it. So it's asking you, find the energy density in kilojoules per gram of glucose and tristerin. So what the heck does that mean? Well, the clue is energy density in kilojoules per gram of tristerin and glucose. So how many kilojoules are in a gram of tristerin? Actually, I'm going to write it out the proper way. Ooh, I erased it from previous. C57H. Where are you? 11006. Okay, good. And this is glucose, C6H12O6. All right. Well, we want to get from kilojoules to gram. The information, looking at what we have moles. That doesn't really help. Oh. But look, at each of the equations, I have my enthalpy of the reaction. It's kind of like the heat energy of the reaction. For glucose, the delta H is equal to negative 2H03 kilojoules per mole of C6H12O6. And it's negative because it gives off energy to the surroundings. And then the delta H for tristerin is equal to negative 37,760 kilojoules per mole of C57H110O6. Okay. Now, energy density is a thing that we use when we compare fuels, because it looks like, wow, that's a lot more per mole. Look at that. But who knows what's more capable? What's a better fuel? Like if it's sure, this might be more per mole, but what if a mole is really big and you actually get more energy per certain amount of fuel in glucose? So we're trying to figure this out. We're saying which one is a better fuel by gram, per gram. So we want to see how many kilojoules per gram of each of these. And then I can go, oh, I'll take a gram of this, please, because that has more energy, or this one. So let's find out. But we're given kilojoules per mole, and we need to go kilojoules per gram. Now, the way to do this is if only we knew the mass of a mole of C57H110O6. Well, we do. Can we find the mass of a mole of 57 moles of carbon, 110 moles of hydrogen, and 6 moles of oxygen? Yeah! That's called the molar mass. So what you do, kids, is you start over, you have the energy, the enthalpy of all these terms. 760 kilojoules, okay? And you find the mass of a mole of C57H110O6. You add everything in the periodic table. It's kind of a pain. You end up with 891.45 grams of C57H110O6. This divided by this, and you end up with 42.4 kilojoules per 1 gram of C57H110O6. Okay. Do the same thing for glucose, and maybe we'll leave the negative out there. It's really just asking us how many kilojoules per gram. You know what? The negative makes sense when talking about a reaction. We'll leave it in there for now, but we're really just looking at the numbers, so don't sweat it, folks. Okay. Let's do the same thing for here. We have the same amount of energy, 2803 kilojoules per mole of C6H12O6. Do the math. And you end up with the molar mass of glucose, a little bit easier, 180.16 grams C6H12O6 in 1 mole. That's it. That's 1 mole, right? So this divided by that, 15.6 kilojoules per gram. That's what the gram. So if I have 1 gram of sugar, it gives me this many kilojoules of energy. If I have 1 gram of tristerin, though, I have 42.4 kilojoules. So that's way more energy. So it's pretty amazing. This is a lot more energy per gram. Which goes to the next question. If I had 5 grams of this and 5 grams of this, which one gives us more energy? Well, there you go. What do you think? This is for 1 gram. How do you find out how many for 5 grams? You just multiply this by 5, and you end up with the kilojoules. Well, let's do it. Let's go backwards. I'm gonna go here. All right. So we've got our 2 energy densities. Times 5. I'm going backwards. I don't know what to do. You can guess that this is going to be higher, right? Because it's a bigger number. But for all you math heads in the world, 77.8. And let's get rid of the negative because we really don't need that right now. Kilojoules for 5 grams, and this is, oops, I don't know how to read. 77.8 kilojoules, and this is 211 kilojoules. So for 5 grams, way more for tristerin. It's the more energy efficient fuel per gram, pretty much. So eat your fat, kids.